and welcome to episode number 61 of the weekly Google Cloud Platform podcast. I am Francesc, and I'm here with my colleague, Mark Mandel. Hey, Mark, how are you doing?
I'm good, thanks, Francesc. All the better because we're in the same room at the same time.
Finally, for not that long, but finally.
For a little bit.
For a little bit, just a week. Finally back from Europe and still not in India. So there you go, San Francisco.
Yeah.
And we have a very interesting episode that, I'm excited about it, but I know that you're even more excited because, video games.
I seem to be very excited a lot lately. I've noticed it seems to be a recurring theme.
You're always excited. I'm always excited, but you're always excited about this episode. Lately, we've been having pretty cool episodes. And actually, the two next episodes that we're going to be having, we already know what they are. And they're also very exciting.
They're also very exciting. Yeah. Yep. So this week we have Rob Whitehead, a CTO at Improbable, joining us. Improbable is a company that helps you build massively online persistent worlds. And so we're going to chat with them. They run on GCP. It's a pretty cool partnership we also have with them. So we're going to talk all about that.
Yeah. Very interesting conversation talking about how to basically, how would you do it if you had to build the matrix? Kinda,
yeah.
Yeah. A very, very interesting conversation. That's for sure. And
I want to be the architect though. I get to be the architect.
You don't really have that beard, though.
That's true.
Yeah, sorry.
Oh well.
Yeah, sorry. No,
that's okay.
If we were to have an architect, we know who that will be, and he works at Google.
That's true. That's totally true.
But anyway, at the end, we'll have the question of the week, which is about resizing disks.
Yeah.
Something pretty normal and not that exciting, but you might need to do it at some point, and knowing this may make your life so much easier.
Definitely.
But before that, we're going to go with our cool things of the week, and they're seriously cool.
They are seriously cool. I know the first one you had a fair bit of involvement in. Yep. I see that Google Cloud Endpoints is now generally available.
Yep, we hit GA, and it is pretty amazing. That's actually the topic I'm going to be talking about during my Cloud Next talk in 2-3 weeks.
Yep.
I think that the most interesting, the cool thing about Cloud Endpoints is the fact that it allows you to do many things that you need to do, but without any effort. Okay. Such as managing, you need to do logging, you need to do monitoring, you need to do authentication, you need to do all of those things. With Cloud Endpoints, you get to do all of those, but just having a Swagger spec or Open API specification, which is pretty awesome.
Yeah.
It's in the Kelsey Hightower scale of dopeness. It's pretty dope. So it is a very cool thing to have. Check it out. It is now GA, and there's a bunch of things that it does. It is supported on GCE, on GKE, on App Engine for Java and Python, and actually anywhere else. You can run it anywhere. We have a small Nginx proxy that you can run anywhere.
Cool.
Yeah. So pretty cool.
That is very cool. Now, the second cool thing of the week is super cool.
Yeah, it is globally, what's the word? Globally consistently cool?
Ooh, I like that.
It is a globally consistently cool thing of the week. We released Cloud Spanner, which is our Spanner product as a service.
Yeah, so the public beta for Cloud Spanner, a globally distributed relational database service.
Yeah, and it is, it is pretty amazing because if you think about it, it's basically like we had already an episode on Bigtable, and Bigtable is kind of a big deal. I see Spanner as an evolution of Bigtable because you're basically providing things that normally you only have in relational databases, but globally distributed and consistently and available, which, it is kind of crazy.
Yeah. So you have all your traditional SQL stuff. So you've got your SQL, you've got schemas, you've got consistency. That's great. But you've also got really high availability, horizontal scaling, basically up the wazoo, to a global level, and automatic replication and global transactions and consistency. It's pretty crazy. We're going to definitely do a whole podcast topic on it, but there's a couple of blog posts that you can read about it right now.
Definitely deserves a full episode if it's not more than one. But for those that might have cringed when I said that it is both consistent and globally available, that is good to cringe. We have an article explaining why it is not really true, but almost.
True enough.
It is true enough. It is not completely available, but the availability is so high that it is basically globally available. So we have a bunch of links in the show notes. So you can read that cap theorem white paper on Spanner, but there's also a bunch of other ones that you may be interested by. There's also a bunch of different tutorials that you can try. There's one for Go.
Oh, cool.
Which is pretty nice, but also Node.js and I think Java and whatever you want to do. So go have a look, play with it. It is pretty amazing.
It is indeed. Cool. So why don't we go have a chat with Rob at Improbable then?
Let's do that.
Sounds good. Today we are joined by a very special guest. I think they're always very special guests, but a very special guest. Rob Whitehead, CTO of Improbable. Rob, how are you doing today?
Yeah, not bad, Mark. How are you doing?
Very, very well. Thank you so much for joining us, coming to talk to us about Improbable, about SpatialOS. Before we get stuck into that, why don't you tell us a little bit about who you are and what you do?
Yeah, sure. So I'm Rob. I'm co-founder and CTO of a tech company called Improbable. We're based in London, about 150 of us. Previously, I kind of started Improbable fresh out of college in 2012, where I kind of met my co-founder Herman in Cambridge. And my roles evolved over the years from working on our core technology to now kind of looking after how the product, which we'll talk more about, SpatialOS, is being specifically applied in the games industry.
Cool. So, to be honest, for me, it was the first time I heard about Improbable was when I read a headline saying something that Improbable teams with Google. And I actually didn't realize it was a company name. So I had some hard time parsing the sentence. Could you tell us a little bit for people that don't know people that are not like Mark into video games that much? What is Improbable? Why is it important? What do you do?
Yeah, sure. So it's probably worth telling a little bit about this kind of story behind to where we got to SpatialOS. In the early days of kind of hanging out with Herman, we had this dream for a kind of a truly living world video game whereby, traditional games are kind of constrained either in terms of their scale or in terms of the fidelity of the world. So you'll get kind of very large open world games, which are very limited interaction, or you get kind of very, very smaller, more high fidelity worlds, like a game like kind of Battlefield. And we wanted to build a game that was a truly living world where there were kind of millions of trees or millions of animals, monsters, and the players themselves were completely incidental inside that world, and it had huge amounts of physical fidelity. And we knew we'd never really seen games like that before. And we kind of knew that, this necessarily would require us to come up with a way of having multiple computers in the cloud cooperate together to simulate the same space, because the world was going to be too rich and too large for a single machine to ever deal with. And, as we kind of evolved, we moved from our kind of early prototypical ideas of building a game into kind of building this foundational simulation platform, which is kind of what we're doing now.
Cool. So, all right. So you've built this platform called SpatialOS. What can you do inside of it? Is it just games, or what's the possibilities?
SpatialOS is a platform for building simulated worlds. So what do I mean by that? Any problem you have which involves a set of entities, which are things, and they interact in kind of unexpected and complex ways, and the scale of those interactions and the kind of fidelity of those interactions is so large that you want to be using the power of multiple machines, SpatialOS nails. So, if you're kind of trying to simulate a very huge game world, then you're going to have, lots of player entities, you're going to have monsters, trees, inventory items. If you're simulating a city, those entities might be cars, road segments, traffic signals, pedestrians, buildings. It really depends on what domain you're modeling. And to kind of get a bit formal about it, it's kind of in the realm of kind of complex systems modeling. It's modeling systems where you have lots of little things interacting, and then you get kind of crazy emergent consequences from that.
Awesome. All right. So this is the Google Cloud Platform podcast. Usually we talk about how you use Google Cloud Platform. But as well as that, I think it's worth noting there's a partnership here between Google Cloud Platform and Improbable as well. Do you want to talk a bit about how that works and what that provides for developers?
Yeah. So, I think both Improbable and Google agree that, SpatialOS lets people kind of, build fundamentally new kinds of game experience with these kind of really massive, simulated, meaningful worlds. But it also lets smaller teams do so. And the idea of our kind of games innovation program is about enabling game developers to get credits to start developing with SpatialOS, for free. and like sort of essentially you have credits so that rather than, when you're developing your game, you have to kind of pay for the compute being used, you only have to pay for the compute after launch. So it's kind of about like sort of helping you kind of get up and running and like sort of not be afraid of really pushing the boundaries in terms of what you can do.
Sweet. So GCP's partnering with you to help power that whole program.
Yeah, exactly.
Perfect. And if people are interested in the program or they want to build something on SpatialOS for that program, is there any information or upcoming or available right now?
Yeah, so we're going to be announcing the specifics of the program closer towards GDC. But right now, like sort of anybody who kind of like sort of signs up through SpatialOS.com will be eligible to kind of apply for the program. So if anyone's interested in kind of going through, I'd recommend they go to SpatialOS.com and go through those steps.
Cool. So I wanted to know a little bit about how, like you said that there's the name of the OS, SpatialOS. Is it really an OS? What does it look to be a developer and to build something on top of it?
Yeah, sure. I mean, that's a really good question. So SpatialOS is a kind of class as a distributed operating system. So when you kind of have traditional operating systems, Android, Windows, they run on a single machine. SpatialOS is kind of a layer above that, which lets you take multiple computers and kind of consider them to be one big computer and kind of present an abstraction on top of that. So specifically, SpatialOS runs on top of CoreOS on a cluster of machines in the cloud, and then gives you APIs so you can treat it as kind of almost one big supercomputer.
Nice. So it kind of sounds like it's like video game specific Kubernetes, almost.
Yeah, I guess like sort of the core abstraction is you kind of look at, traditional, well, it's a platform as a service, and you kind of look at kind of traditional platforms as a service. We had the early days, we had like sort of tools like kind of Google App Engine, which are about kind of a stateless web application with some persistent data backend. And that was great for a certain group of people. If you want to build like sort of certain kinds of mobile backend, or you want to build like sort of a web app, you can just nail that out really fast. And then you kind of had sort of more flexible platforms like Google Cloud Functions, which let you kind of have these like transient pieces of computation acting, and responding to things like a pub sub bus. From our side, we found there wasn't really a kind of a platform with an abstraction that was really about kind of creating these large scale simulated environments. And SpatialOS, we kind of felt like it filled that in. So rather than thinking about your kind of, your cluster of machines as a set of, a bag of containers, like with Kubernetes, you think about your cluster of machines as a 3-dimensional space. And it's kind of a pretty crazy abstraction, but it actually works. So you think of your cluster as a huge kind of 3-dimensional space, and inside of it, you put entities, and those entities are the things I talked about before. In your city simulation, they're your vehicles, your roads, your traffic signals. In your video game, they're players, monsters, loot, all that kind of stuff. And then under the hood, we're kind of, partitioning up the data and computation of that world across a cluster behind the scenes for you.
So if I'm a developer who wants to build something on SpatialOS, what does that development flow look like? I think you mentioned maybe there are command line tools, or like how do I build something from start to finish with, say, like an engine like maybe Unity or something else?
Yeah, for sure. So it's worth saying, sort of from our side, we really believe in kind of people taking the tools they're already familiar with to kind of use our technology. So let's say you're kind of traditionally used to building like a dedicated server based multiplayer game in Unity. You'd have a Unity dedicated server probably built out in Linux running, and you'd probably put it on some either dedicated machine or on some VM, and you'd have some clients go and connect to that. So with SpatialOS, you kind of download our SDK, which is just a series of command line tools. And like sort of, and web UIs essentially. And, you kind of get plugins which actually tie into whatever game engine you're using. So whether you're using Unreal, you're using Unity, or you're using kind of your own game engine, this essentially, handles your connection into SpatialOS and handles kind of, taking the part of the world which your kind of engine is simulating and synchronizing it with the broader world. And, you pretty much like have business as usual. So like sort of once you've built your application using kind of your kind of game engine of choice, you build it out into what we call an assembly, which is almost like a distributed executable. It's the kind of this application which you're going to kind of push into our platform, and it's going to run across lots of machines. And from that, you just use a single CLI command, just like spatial deploy, and it takes your kind of built out Unity application and pushes it into our platform. And then it carves out those VMs and that cluster behind the scenes. And then instantly you've got a kind of a simulated world running there kind of up in the cloud. And the next step is, you can take a URL to that and share it with a friend and have both of you log in.
Cool. But does that mean I have to write in like some sort of custom language, or am I escaping my usual set of tools, or how does that work?
No, so you can use like sort of your existing set of tools, be it, Unity, Unreal, whatever game engine or whatever kind of tool you want to be using for that. The thing which kind of binds us all together and the kind of magic is traditionally like sort of worlds would be built or ran from having a single kind of dedicated server running in the cloud. Now there's a cluster of machines. So concretely for a game like Worlds Adrift, we're actually running hundreds of instances of a game engine like Unity in the cloud cooperating together to simulate a world much bigger than any single kind of, one of those engines could ever understand. And then plugging into the world as well, you can have, like sort of well over 1,000 clients interacting in the same physical environment. And again, that's kind of much larger than, a single game engine could ever deal with. And that's because SpatialOS is this distributed cluster handling the, in-memory persistence of all those entities as they mutate, handling the kind of like sort of network fan out of you kind of like, moving around the world and having all the things you're seeing streamed into you.
So going on the developer experience of SpatialOS, I'm curious about if MapReduce, the hello world of MapReduce, is counting words. What is the hello world of SpatialOS?
So if you go to our GitHub, you'll find there's actually an example kind of game simulation we call Hello World. And it really is kind of try and demonstrate the kind of core aspects of kind of what the technology does. So Hello World there is I guess we kind of coined this term MMOBA, which is kind of, I don't know if it's going to like catch on, but it's this idea of kind of like this Hello World project has two teams and the two teams are running at each other, these little wizards. And they kind of start with very small amounts of characters and they kind of build up and up and up until there are kind of thousands aside kind of like sort of attacking each other. And the cloud deployment has two instances of Unity overlapping and co-simulating to simulate the entire space. So it's kind of a good example of something showing, an interesting like sort of game environment with kind of emerging complexity and interesting gameplay mechanics. It's got the two workers cooperating together, demonstrating that, SpatialOS is letting you use more than one machine. And yeah, that's like the kind of foundational thing you tend to jump off from.
Nice.
I've played it. There's lots of fire. It's fun.
Yeah, Mark set me on fire. It wasn't very friendly.
That's what friends are for. Cool. All right. So now I'm also curious, right? So SpatialOS sounds great. Platform as a service for these massively online games. Why does SpatialOS and Improbable use Google Cloud Platform? Like, what are you using on us as products?
Yeah, sure. So like sort of, although as a developer, you kind of interact with SpatialOS under the hood, with the kind of innovation program, like sort of we run on Google Compute Engine to actually like sort of, run those VMs. So like sort of when you create a SpatialOS deployment, you're going to be using like sort of, Google VMs to kind of, get requisitioned and start. And there's kind of, the thing we found with Google VMs is specifically around kind of their provisioning time. So like sort of if you're a small group of, indie devs and you're trying to do a game jam and you want to be iterating rapidly and, pushing your simulation to the cloud, like sort of having like a tight provisioning loop is really good because it's the amount of time you go from a CLI command to actually having a game running in the cloud you can go and play. And we found kind of, GCE was kind of like sort of specifically good for that. And the other side, which is kind of something to bear in mind with games, is a lot of the web is kind of built around TCP. And it's built around these kind of request response connections, a lot of JSON. And when you kind of like sort of move towards applications like games, you're actually dealing with fire hoses of unreliable UDP packets. And traditionally, like a lot of clouds haven't really been set up to kind of be particularly good at routing that kind of traffic. And like sort of from our side, we found like sort of Google Cloud Platform was a good choice in terms of like games networking as well.
Nice. So I think that on top of using Google Cloud Platform, you might have also been using other Google open source projects. Like you mentioned CoreOS, and CoreOS, they say, I think their headline is something like Google infrastructure for everyone. Are you using something like gRPC or?
Yeah, there's actually plenty of stuff to talk about. The first thing, is gRPC, although the kind of the core entity synchronization things within our tech are kind of, bespoke. The platform itself in terms of, requisitioning deployments, getting metadata, all that we kind of use, gRPC. And the reason why we like that is kind of, one is a very, very easy, like streaming responses based upon, HTTP2. And the other side as well is kind of having that kind of binary serialization by default and also having a typed RPC system by default as well, rather than, throwing around JSON. And we found it was kind of perfect for our use cases. I guess a kind of another thing in the Google space we use is Bazel. So we kind of have when you're building a simulation platform, you're building APIs which can, be used in C#, C++, JavaScript, Java, and a tool like Bazel lets you kind of handle a mono repo, which has like a load of different like sort of languages kind of working together in the same build. So we found that invaluable in terms of like a scaling as an engineering organization.
So it's actually interesting. Normally when I hear people using this many tools from a Google open source world especially, they're normally ex-Googlers. You're not ex-Googlers though, right?
So a few people from our kind of infrastructure team are ex-Googlers, and there's a certain like sort of bit of that in there. We have a kind of a good cross-section of different people, and a tech like SpatialOS, you kind of need to have this weird blend of, we kind of have the kind of, ex-large-scale software companies to kind of give that kind of, production at scale, kind of stuff. You've got people from high frequency trading firms who are used to that kind of really low latency, high throughput kind of interactions. And you have people from the gaming industry who are kind of around all the kind of tricks and all of the skills which go into kind of building a very efficient game engine, for example.
So I guess that the next question is, are you hiring?
Yes, we are. So we actually have offices in San Francisco. We just set up recently there. And we also have our kind of our home base in Farringdon in London. So there's kind
nice.
of, we have a lot of us hanging out there. And yeah, we're kind of always looking for kind of, in people who are interested in this kind of thing in terms of building large scale, reliable infrastructure and simulating the world or building the matrix.
Wonderful. So, curious though, so you're building, it seems like almost a very different type of platform from what people have built before. What were some interesting challenges you faced when building SpatialOS?
Yeah, we had many like challenges on our quest. It was definitely worth saying. Some kind of like sort of fun stories to talk about there. One is kind of when you start running, like normally a game will kind of run with a single server binary kind of running in the cloud. And occasionally it will crash, so this stuff is high performance C++ code. Sometimes it's going to have issues. Yeah. So traditionally when you run a single dedicated server, you'll find that it's written in high performance C++ code and occasionally it might crash. But what happens when you run 100 instances or 1,000 instances of that kind of game server code at the same time as a kind of swarm of microservices? Statistically speaking, the probability of any one of them failing goes up and up. So, we had kind of to bake into the core of our platform the fact that these workers can fail. And, how that works is we actually have the in-memory representation of the world. So every entity, every, player, rock, character has an in-memory representation within the SpatialOS runtime of their state. And these workers are kind of almost streaming processes. They're kind of pulling in the data of the world around it, computing on simulating parts of the world and streaming that back into SpatialOS. So at a moment's notice, if any of those kind of workers were to fail, we can, rush in and actually replace them with another worker who can be given that information to continue the computation. So that's kind of one really kind of fun problem. When I say fun in retrospect, obviously they were incredibly tough things to get through. So I guess one of the most interesting challenges we had to solve is the fact that physics engines, when you run a single instance of them, they'll actually use non-determinism in how they solve their physics to actually increase the numerical stability of the result. Mm-hmm. So you can imagine a big pile of boxes kind of being simulated by kind of the algorithms inside of them. By randomly shuffling the order which those things are processed, you end up with a kind of better result mathematically. But when you start to have 1,000 instances of those physics engines overlapping and cooperating together, you get these really fun scenarios where you'll have overlap regions, where kind of both of them are interested in the same world, and they might actually simulate slightly different responses. So from that side, we had to produce kind of strategies and algorithms for essentially blending their truths together after a certain amount of time. And that was a really interesting challenge where now we can actually have a pile of boxes on top of each other whilst migrating the authority of those boxes between two physics engines multiple times a second, and the physics simulation is still stable. So that's kind of the way kind of we think about it is almost eventually consistent physical simulation. And that was kind of something we kind of invested a lot of effort in the kind of early years.
My head's exploding.
Yeah, I could see.
Is that too crazy?
No, I'm just thinking about it.
It does make sense.
Yeah, it makes sense.
Yeah.
But the non-determinism.
I've got another little cheeky soundbite thing I can say, which is about the line of dominoes. It's actually my favorite one to kind of describe the technology.
Yeah, go on.
Yep. I guess kind of one of the easiest ways to kind of break down SpatialOS into its most base example is a game which we're not planning on making, but let's call it Domino Simulator 2017. So in Domino Simulator 2017, there are 1 million dominoes, and you can flick the domino like sort of on the right side and have it cascade, and eventually it'll knock over the domino on the far left side, a million down. Imagine you wanted to simulate that in real time and have, people able to kind of participate and see that. The issue is a single physics engine wouldn't be able to simulate the physics of a million dominoes at the same time. But we probably have physics engines that could simulate maybe 1,000, 10,000 dominoes at the same time. So let's say, we actually bring up 1,000 physics engines, all kind of, next to each other to simulate that entire set of a million dominoes. Well, you're going to get an issue where, when you flick the domino on the far right and it starts cascading down, you get to the point where it needs to kind of interact with the next physics engine. And this is kind of a very, very difficult problem. And the way it works is you can think of every entity, every domino in the simulation to have almost a bubble around it. Imagine a bubble of kind of, maybe like half a meter in real life terms. And that represents you can think about if I was to simulate the physics for that single domino, what other things could actually act on that at any point in time to affect it? Well, maybe the domino is very nearby it, but the domino kind of a million dominoes away might eventually affect it, but it's not going to instantaneously affect it. And this idea of kind of bubbles of simulation and synchronizing the right data to the right physics engines at the right point in time is a lot of kind of what the kind of core hard technical problems of SpatialOS are all about.
That is pretty cool. So we were talking a little bit before about the Hello World and like what are the basic things that you can build with SpatialOS. What about the other side of the things? What is the biggest game that has been built with SpatialOS?
Interesting. So I can talk about games. The other thing I kind of want to talk about is like sort of some of the kind of more like geographically explosive things that are now kind of non-games applications.
Oh, yeah.
So specifically, one example is where somebody kind of came in for a week to jam with us, and they had knowledge in kind of internet network routing. So essentially the border gateway protocol, which is kind of how all the kind of like sort of trunk nodes of the internet kind of find out how to route to each other. And they kind of simulated like sort of every single node, just like kind of 45,000 nodes in the entire internet, and could have a real-time simulation of how those nodes reacted to failure. So you could be like, what happens if I pull out this plow cable? How will the internet react? And how will it kind of move around its kind of its routing of internet traffic? And that kind of thing was like really exciting, seeing, a small group of people come in, they model kind of, some interactions between two entities with a well-known like sort of set of interactions, and then they could like scale it up to this massive scale. And I think like sort of one of the fun things about like BGP is every single node has to know about every single other node and how to route to it. So you kind of get this really fun, like, there's kind of like sort of every single node has every other node's routing information in it. So it kind of grows with very, very fun computation, like memory complexity. So it was interesting seeing how much memory we had to consume to actually do that.
So that sounds super interesting. Do you have any like numbers you could share in terms of how big or small that was, or like how many entities were being like used inside that simulation?
Yeah, so like sort of with our internet simulations, it's kind of more about the entities themselves being very heavyweight and doing a lot of kind of algorithmic complexity. Mm-hmm. There are kind of like sort of other simulations in our kind of city simulation space, which are in the order of tens of millions of entities in terms of, representing buildings, roads, traffic segments, vehicles, pedestrians, which are kind of pretty exciting. And then in terms of our gaming applications, there are kind of games like Worlds Adrift, which are using, millions of entities interacting there, and they represent kind of, either from a tree which you can chop and it will physically fall over and break into pieces, mm-hmm. to creatures that fly around and they kind of, mate with each other and have a real kind of like sort of ecology around them, to players building ships out of physical parts. So you can build like a floating skyship out of hundreds of different panels and engines and guns and different pieces, and every single one of those things is an entity which is persistent. So if you crash into another ship and one of those panels falls over and lands on the ground, that will actually persist indefinitely because it's stored inside SpatialOS's in-memory representation, which again is regularly snapshotted out. So even if kind of someone goes away and comes back again later, it'll still be there, because rather than having the transient state inside of these game engines, it's actually in a persistent layer on top.
Awesome. All right, so we're slowly running out of time. Where can people go if people want to go to events or things like that? What upcoming events or appearances are you all going to be at?
Yes, I think so. It's a big couple of weeks for us. I think the first stop is us at GDC. So we're going to be kind of like, so if you go to spatialos.com/GDC, this is going to be telling us all about the events we're running there. We're going to be running some panels. We're going to be doing a couple of like kind of on-stage presentations, and we also have a booth like sort of nearby Google Cloud Platform, actually. You can come and find us. We're going to be putting on some evening events, which you can find out more through that link. And after that, the week after is going to be GCP Next. And we're going to be kind of hanging out there. I know Herman, our CEO, is doing a talk. I'm going to be on stage with Mark talking about some more Spatial Os. It's going to be good fun. And yeah, that's probably like sort of the next kind of things on our radar for events.
So I have one more question that I need to ask before we finish the interview, which is, why is the company called Improbable?
Oh, that's a really good story. I don't know. I see where I can go with this. So actually, if you look at our kind of legal incorporation status, the name is Improbable Worlds. And I remember as kind of we hired a very, very edgy design agency, and they were hanging out with us. And I remember the last thing they said to us, like, drop the worlds, and then kind of walked out in a kind of quite enigmatic fashion. So yeah, I guess like sort of the other side is like it really kind of has come to reflect a lot of the values we have as a company. Really about kind of trying to do things that have been done before and failed. Specifically these kind of large scale simulations. So it's something we like. It's something which kind of was definitely caught on.
Awesome. Well, Rob, thank you so much for joining us. We really appreciate you taking the time, and it's been a great conversation.
No, thanks very much.
Thank you. So thanks so much to Rob for such an interesting interview. I learned a lot, and I gotta say that after talking so much about all the kind of simulations you can do, I want to try it.
Yeah, it's really, really, really cool tech and loads of fun to work with. Getting huge amounts of things interacting with each other, it produces really interesting behaviors, and like weird stuff happens, and it's fun.
Yeah, like I don't even want to build a game. I just want to build a little simulation, like the game of life.
Yeah, or like ants or something.
Yeah, like I just want to build something like that. Sounds super cool. Maybe during my trips, who knows? But before we finish with the podcast, we have our question of the week.
Yeah, so I'll ask the question of the week. So in Google Cloud Platform, we have these things called persistent disks. We normally mount those on virtual machines so that you can write files to them and like put data in them and all that sort of fun stuff. Sometimes disks fill up, and that tends to be bad.
Yeah.
So one option is to delete stuff off disk, which you may or may not want to do. The other option is just make the disk bigger.
Yes. Or add more disks.
That works too. But let's go with making a disk bigger. I think that's just easier. Is there a way I can make a disk bigger while not having to like take down my machine or turn it off or do anything like that? So
this is actually very interesting because I think that the first time I had this question was during a training, a GCP 100 training. And I thought the answer was, well, you can create a snapshot of the disk, then create a new disk that is bigger based on that snapshot, so you have the same data, and then swap the disks.
That doesn't sound like fun.
I mean, it is doable, but it turns out that I was wrong, or now I am wrong in any case, because there's a way easier way to do it, which is you just go to the console, and then you click on Edit on the disk, and you resize it. No matter if it's attached to an instance or not, you can actually do this, which is kind of an amazing thing to do. And then the second part that you need to do is you actually need to let the OS that you're running on that instance realize that the disk changed its size. So you might need to change the size. So for instance, if you're doing Linux, I think there's a command called resize to FD something.
I think that's right.
There's probably you can follow the documentation for that one, because resize to FD something might not be the actual accurate name, but basically that's what you need to do. You first resize it from the console, and that is independent for whatever system you might be running, and then according to the system you need to resize that partition, and that's it. So you basically are able to resize any disk with zero downtime. Except if that disk is a root disk. If it is a root disk, then you still need to go through that older process that I was talking about, where you create first a snapshot of the disk, and then you create a new disk based on that snapshot. So you can still do it, but it's a little bit harder, which kind of makes sense because root disks are root and special.
And they have the operating system on them and other fun things.
Yeah. So, it is a little bit more complicated to handle with, but yeah, it is. I think it is a simple thing, and it's so simple that sometimes you don't think about the fact that you can just click on edit and change things while they're running and everything just works.
It's fine. Everything's fine. Wonderful. All right. Well, Francesc, are you doing anything interesting? You jet setting around some more? I know you like to.
I never
pop around
do
a bit.
interesting things. Never do interesting things. So I'm actually today is Wednesday, which means that tomorrow, Thursday, I will be speaking at GoSF.
Nice.
For the Go 1.8 release party. Lots of really cool things coming on with Go 1.8. So we're going to be talking about those. I'm specifically going to be talking about context, the Go context. But there will be other talks about the different topics that are new to the new release. Then the week after that, I will go to GopherCon India, which will be in Pune. Which, by the way, we received an email saying that it is actually pronounced Pune. So thank you so much. Now I know.
I think we actually got more than one.
Yeah. So thank you so much. Now I know it's pronounced Pune. So very excited about that. And then I'll be a couple of days in Mumbai. I'm trying to organize an event in there. Then I'm coming back for Cloud Next. And then I'm leaving again for GopherCon China in Shanghai. And I'm very excited about that one.
Woof.
Yes.
That sounds good.
I don't travel. What about you?
What about me? So I will be at Game Developers Conference. I'll be everywhere, just everywhere. I think I'm just going to be everywhere. We are hosting the Google Developer Day. I'll be doing a sponsor talk first thing Wednesday morning for Google Cloud. I'll be doing a lightning talk on the Developer Day as well. We're also sponsoring a variety of events around the conference, including like Women in Games and Girls Make Games and things like that. It's going to be loads and loads and loads of fun. After that, yes, I'll be at Next as well. We'll both be at Next.
Good.
Doing our podcast thing and doing some talks. Strangely enough, one with Improbable myself. Once we're done with that, it looks like I might be doing some stuff with Vancouver. I need to travel up there for some stuff, but we'll wait and see what's happening there. But after that, I'm doing a little East Coast tour. I'll be doing the East Coast Game Conference. That'll be the 18th of April. And then right after that, I'll be traveling up to the Vector Conference in Kentucky on the 21st.
Nice. Sounds like lots of fun.
It's going to be lots of fun.
Cool. I guess it's time to finish, but before we finish, we have not done this in quite a while. So let's go through all our different ways of people contacting us.
Sure.
So we have Twitter.
At GCP Podcast.
And Google Plus.
At plus GCP Podcast.
And we have a webpage.
GCPpodcast.com.
With an email.
At hello GCP Podcast.
At hello GCP.
Oh, hello GCP Podcast.
Hello at GCPPodcast.com.
That works too.
Complicated. And then we are also on Reddit.
/r/GCP Podcast.
And finally, we are on Slack.
The Hash podcast channel on the Google Cloud Platform Community Slack, which can be found on bit.ly/GCP-Slack.
Wow. What a mouthful.
There we go.
Great. And send us your questions, your messages telling us if we're mispelling things, mispronouncing.
Mm-hmm.
We probably misspell things, but you cannot see them. So, yeah. And also, if you have any ideas for episodes, we are always looking forward to your comments.
Absolutely. And if you want to come on the podcast, feel free to reach out.
Absolutely. So, anyway, thank you so much again for an improbable episode.
Yes, and thank you very much to everyone for listening. And see you all next week.
Yep, see you.